All right, you guys, trying something new with the videos, hoping they'll be more interesting. This is your homework for 4.1. All right. Here is numbers 1 and 2. 1 and 2. We have an equation. C of x is 50 divided by x. It represents the time it takes in hours for a car to complete a 50-mile trip. So that's that 50. And x is the speed of the car in miles per hour. What is the value of C of 20? Guess what? I didn't even actually need to read any of that to answer this question. C of 20 means when x is 20, what is y? And remember, C of x is y, all right? So this basically just means to plug 20 right in for x right there. So C of 20 is 50 divided by x, and x is 20. So this is 2.5 hours, all right? What does C of 20 tell you about this trip? C of 20 tells me that if I go 20 miles per hour, it will take 2.5 hours to complete the 50-mile road trip, okay? All right. Next, we have a graph of A of x, and that's A of x. They want me to write two statements that are true about it. You can do this a couple different ways, you guys. You can plug in values and calculate, or you could look at the graph. Like, for example, I notice that when x is 2, it looks like y is 20, all right? So I could write A of 2 equals 20 just off of the graph, all right? It's also true to just plug it in right here. 20 divided by 2 minus 1 is 20, all right? Another true statement, plug in whatever you want right there. Whatever you want, literally whatever you want. It doesn't even have to come out nice. I thought of 5. 5 does come out nice. You get 20 divided by 5 minus 1, which is 20 divided by 4, which is 5. So A of 5 is 5, all right? But it could have been ugly, and that would be fine too. Like if I had plugged in 4, A of 4, I would get 20 divided by 4 minus 1, which is 20 divided by 3. That's what it is, all right? Can't really reduce that further. I could punch it into the calculator and get a decimal, and I don't like that. So I would keep this one 20 over 3. Possibilities, you guys, right here are endless, all right? Let's see what's next. Okay, now they want me to write a false statement. Also, endless possibilities, you guys. You could plug in that, I don't know, A of 5, that we know from the previous problem is 5. You could write that it's 4, or 2, or -1, or 800, all right? And that would be a false statement, all right? Complete this statement. When x increases more and more, A of x gets closer and closer to, all right, you guys, my x is increasing more and more. That means bigger x values. It means I'm moving further and further to the right. And it wants to know what A of x does. And remember that A of x is y. So it's asking me what y value I'm getting closer to as I go further and further and further to the right. I'm getting closer and closer and closer to a y value of 0, all right? All right. Now we have a function b of x. B of x is 16 divided by x. They want me to complete this table. Okay, so b of 0.1 means 16 divided by 0.1. which is 160, right? They want to know b of what is 8. So 16 divided by what is 8? And that's 2. And now they're asking about b of 80. So that's 16 divided by 80, which is 2/10, 0.2 or 2 over 10 if you reduce the fraction. Either way, that's our table, okay? And now we're gonna see what Marcella is thinking. Marcella is thinking that there might be an asymptote, maybe, when y is 0. What's another x value that she could test to see if she might be correct? All right, an asymptote at y equals 0, meaning we approach y being 0 without ever reaching y being 0. So looking at this table, I started at 160, went down to 8, now I'm at 0.2. I notice that the bigger the number I plug in right here, the smaller this gets. And already at 80, I'm pretty close to y being 0, all right? So to test if that's actually an asymptote, I would plug in a really big number, okay? I wouldn't plug in something like a little bigger, like 100 or 200. I would plug in something outrageously large, like, I don't know, that, okay? Or to make it a little, it doesn't matter, that works, all right? And so then you will see if you do that, that you get 0. That, all right? Which this is like so close to 0. And then we can kind of start to see the pattern that that does help us figure out if Marcella's correct. It's looking like she's correct. Okay. Let's see what's happening here. Which point is not on the graph of this function? Okay, let's see. I have 25 divided by x plus 1, and let's just check them one by one. What happens when x is -1? I get 25 divided by -1 plus 1, which becomes 25 divided by -1 plus 1 is 0. And as we learned today, all right, dividing by 0, error, all right? We can't do that, all right? You can't divide your cookies between 0 friends. It doesn't make any sense. So this guy right here cannot be on the graph, because when you plug in -1, you do not get 0. The rest should then be true, all right? But just quickly checking, if x were 0, this would be 25 divided by 1, which is 25. If x were 4, this would be 25 divided by 4 plus 1, which is 5. And 25 divided by 5 is 5. And if it were 9, this would be 25 divided by 10, because we would add 1 to the 9, and it'd be 2.5. So the rest all check out. This is the answer. Okay, let's select all true statements for d of x equals 40 over x minus 2. D of 3 is 40, so let's see. If I plug in 3 for x, do I get 40? 40 divided by 3 minus 2 is 40, all right? Because 3 minus 2 is 1, and 40 divided by 1 is 40. D of 0 does not exist. Let's see. If I take 40 and I plug in 0 for x, so I get 0 minus 2 on the bottom, I get 40 divided by 0 minus 2, which is -2, and 40 divided by -2 is -20, which exists for sure. So this is not true, all right? The first one was true, that one not true, okay? For x greater than 2, the values of d of x are positive. So let's see here. If I plug in a number, 40 divided by something minus 2, if the number I plug in here is bigger than 2, then when I subtract 2, I'll have a positive number. And when I divide 40 by a positive number, it'll stay positive. You could check it with a couple of values if you want, but I am sold. I'm sold on that one being true. For x less than 2, the values are negative. Well, we did plug in 0 earlier, and we did see that it does become negative, and we can test it right here. If the number we plugged in were less than 2, when I subtract 2, this number on the denominator would become negative. And then once I divided 40 by that negative number, it would definitely be negative. And now, does d of 2 equal 0? You guys, this is gonna get you if you are not careful. Plug in 2 for x. 2 minus 2 is 0. And dividing by 0 is a no. All right, when you see that 0 on the denominator, okay, not true, that's not 0. That doesn't exist. That doesn't exist. Okay, cool. Let's see what else they have for us. Oh, this question. Okay, you guys. I tried this in first period with a student, and I was stumped. What are those little lines? Here is a table representing, are these negatives? I didn't know it could be negative. These are negatives, that changes things. Oh my gosh, okay, let's do this. We're trying to put all the digits from 0 to 9 in these boxes, although 2 of them we won't use, so that this table represents this function, all right? So I'm taking 48 and I'm dividing it by x plus 1. Let's try it. All right, you guys, I'm as stumped right now as you guys. Let's see. Okay. Do we dare just try plugging something in like a 1? Oh no, we can't plug in 1. That's insane. That's the one thing we can't plug in. We can't plug in a negative 1 right there. So let's just plug in 1 and see what happens, all right? If I plug in 1, I get 48 divided by 1 plus 1, which is 2, and the answer comes out to be 24. So that so far is okay. Oh, if I put in a negative 4, oh, can't use 4, I already used 4. Okay, if I put a negative 3, if I put a negative 1. Okay, so this is bad. I'm seeing that this is bad. The fact that I used the 2 and the 4 is restricting me there. I'm gonna start over. I'm going to plug in a negative 2. You know what I'm gonna do? This is what I'm gonna do. I'm gonna see what all makes 48. What can I divide 48 by and get integers? So I could do 1 and 48. I can do 2 and 24. I can do 3 and 16. I can do 4 and 12. Can't do 5, but I can do 6 and 8. And then I can do 8 and 6, and 12 and 4, and 16 and 3, and 24 and 2, and da 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 da. And then keeping in mind, whatever I plug in for x is gonna get knocked down 1. All right, so like, I could do, this means I could do 0 and get 48, or I could plug in, I can't plug in a 2-digit number, so that's it. That would use my digits 0, 4, and 8. If I did 2 and 24, I would really be plugging in 1, so that 1 plus 1 could be 2, and I would get 24. Over here, I would plug in a 2, so that 2 plus 1 makes that 3, and that would get me 16. Over here, if I plug in a 3, I would get the 12. And for the 6, if I plug in a 5, I would get the 8. But this one, I can also do the other way. I can plug in a 7, add 1 to it, it'll become 8, and that'll yield 6. Okay, let's see. And then there's the negative numbers that do the opposite. The negative numbers. So this could be a 1, or it could be a 2. That could be a 1, or it could be a 3. That could be a 2, or it could be a 4. That could be a 3, or 4, or 5. Okay. I'm looking now for which of these digits, which 3 of these I could pick that wouldn't have any repeating digits. So there's, I'm really liking 6 and 7. 3 and 12 would use 1, 2, and 3. So then that would knock, and this. Oh no, I would need a 2. Oh my gosh, you guys. I think we found it. Watch. Let's see. If I were to plug in up here a 2, so a -2 plus 1 would be -1, and I would get a -48. So that wipes out 2, 4, and 8. Oh, that's 9. 8. Then if I plugged in a 3, if I plugged in a 3, I would get 12. Ah, no, I used 2. Crap. Ah, and I can't use 0. Oh no, I was so excited, you guys. I thought we had it. Can you put in -0? No, you can't do that. You have to get a negative number. That doesn't work. All right, let's start with 7 and 6 because I do feel really good about 7 and 6. So if I put in 7, 7 plus 1 is 8, 48 divided by 8 is 6. So 7 and 6 are gone. I need now only 2-digit numbers as answers, so I'm done with these. And looking here, if I put a -5 in, -5 plus 1 is -4, and 48 divided by -4 is -12. So that takes out 1, 2, and 5, which means I can use 0 and 48. 0, 4, and 8. Oh, what a problem. You guys, these are fun. They're challenging. They're like puzzles to solve. They are not problems you need to lose sleep over, okay? Don't lose sleep over this, but try it. That was fun. That one was challenging for me. Okay, hope that all made sense. You can ask me about it in class if you didn't get something and you really want to. And now we're gonna move on. And spiral review, you guys, I don't always do these. We do need to be really good on factoring, you guys. If you're not, please go back and watch those factoring videos, all right? I think I put it in all caps in the name of the video. It wasn't before, but I changed it to all caps factoring, all right? There's a problem, and if you watch that video, you should be able to factor this yourself, okay? And get the x-intercepts from there. And then you can check and see if you were right. This is what you should have factored to get, which means x-intercepts at 3 and -2, okay? I'm not gonna do it and explain it. There's already a video. Same, literally the same. Watch that video, okay? That's it, we're done. All right. I don't know if that video doing it this way was better or not. I'll ask you guys what you felt about it. I just thought, man, those staring at the iPad videos are boring. All right, you guys, good luck. I'll see you. Bye.